So this is a flight transformer which help to get charging voltage. So when we have when the charger is on, when charger is on and charging voltage is there, then this relay will conduct, this relay will get turned on, and by turning on it, this relay come directly come here at the battery. This relay is connected at battery positive side. So the both relay get turned on and the voltage get move out from this side, and we get positive voltage here, and we can charge the battery. So this thing is a bridge rectifier. It is a 35 ampere and 1000 volt ampere. So 35 ampere 1000 volt bridge rectifier. It is a rectifier. This act as a blocking diode. One side of this diode we have high voltage, and one side of we have charging voltage. So it is generally used to at the input case when we have main supply, and this will just make a wall like high. It just differentiate. You can say it is a slab. You can say isolation, provide isolation. The charging volt on this side and high voltage on this side. Okay. This capacitor at charging side, this is a charging capacitor, and this section, you can see this section, this is a SMPS of this UPS. You can say it is the heart of this UPS. It pump the voltage to in whole PSDR. Also it feed a voltage to the this control card, because you can see there are lots of IC are on the control board. So this control board need power. These IC required voltage. So we get voltage from this is SMPS section of this UPS. This is our output section, and this is stored here. You can also check the high voltage boost voltage here. You can see negative 400 volt here and positive 400 volt here. You can check the voltage when we have high boost. So this is a case of input, and when the input supply fail, when we don't have input voltage, how this UPS works? We have battery voltage here, and when we press the button from the front panel, like when we press the button, it close the switch, and the voltage which is here, that voltage is also fed to the control card. That voltage also fed to the control card. When the circle is closed, the voltage is analyzed by the control card itself, and control card sense the battery voltage is sufficient to run the UPS, and then it turn on this relay, and that voltage is come directly feed to these coils. This is a coil which is one coil is having positive voltage, one coil having negative voltage. These coil are you can say parallel to battery positive and parallel to battery negative. And voltage, when we have battery voltage here, you can also check the positive voltage on this diode. When we push the on button single time, we get battery voltage here. That means one capacitor is charged. Whatever we have voltage at battery, that voltage is stored in this capacitor. And when we switch it on, when we start the switching, when we push this test button for a second, and when we get a beep and we release the button, then the switching starts. And these MOSFETs, let me show you the MOSFET. Yes, these are IGBTs. So these IGBT switch, when these IGBT switch, and we get high voltage on this capacitor, and that voltage is further delivered to the inverter section. In the case of battery, when we don't have input voltage, in the case of battery mode, this charger will not turn on, because this control card release a command which switch off the switching of this MOSFET, and that voltage is used to run the inverter. That high voltage is used to run the inverter, and the process is similar. this high voltage feed it to the inverter, and inverter invert the DC voltage, and we get AC voltage here. So these are small transformer. You can see these are the driver transformers. So 1 2 3 4, we have like 8 driver transformer in this board. And you can also see the small box, between the heatsink and capacitor. These 4A and yellow color box, these are the fuses. These are the that are the 4 ampere and 800 volt fuse. So whenever when we have high current at the battery side, and this section get heated, and when heatsink is heated more than the rating of the IGBT or MOSFET, and the MOSFET gets short due to over temperature, if we don't turn off the switching, when these MOSFET get or IGBT get faulty, then we get a short circuit, and in that case that high voltage can be damage whole circuit. So to prevent that, APC installed small fuses. One is on positive side and one is on negative side. So when we have short circuit condition, these fuse get blown up, and charger get faulty, and the voltage is supplied that voltage supplied only to inverter. So this is a very good UPS. I say this is a very good UPS, because whatever it do, whatever it when you push the on the when you push on button from the front panel on, in the millisecond it calculate each and everything and give you front panel display. So that is APC. I think I have covered up each and everything, but if I left any something, then I request you, please give your valuable comments, so I can cover up that thing in next video. So thank you for watching this video. Have a good day.